Hey, what's going on, folks? It's Mike here, and today we're going to be talking about the Tiny C compiler. Now, why we're talking about this is just because I think it highlights a nice sort of discussion about engineering trade-offs. Software engineering, after all, as I teach my students and others, and hopefully figure out from watching this channel on various computer science topics, is often just about trade-offs. So what kind of trade-offs are we going to talk about today? Well, TCC, the Tiny C compiler, as it's highlighted here, is basically a compiler that allows you to generate your final executable 9 times faster than GCC. We're going to try to build this here. I've never tried, but we're going to go ahead and see how easy that process is. But again, that comes with some trade-offs here. So let's just go ahead and take a look at the Wikipedia page, which I've got open here. And we'll talk about Tiny C compiler here. So TCC is a x86 64, so 64-bit architecture and ARM processor C compiler, initially written by Fabrice Bellard. So basically, as my understanding is from looking at the website, which we'll go ahead and pull up here as well, is this is a project that Fabrice had worked on from, look at the copyright, 2001 to about 2018 where he's active. And if I was looking around at the mailing list, it looks like there are mirrors created of the code base, both on GitHub and other places, and folks are still actively hacking on this, which is pretty cool here. So anyways, it is a project that is alive as far as I know. I don't know how active, again, it is, but there are various repositories, Git repositories. In fact, if we go ahead and pop over to one of these, let's go ahead and just see when the last commit message is. This is saying the last stable release here, which almost looks like it reached a 1.0 version here, is almost available here. And we'll see if that pops up here in a bit. Otherwise, we can actually just go to one of the mirrors here. This is the first mirror that showed up here. And let's say people, 2 weeks ago, folks are working on stuff, contributing to various things here. So it's cool to see that it's still a live project here. And sometimes that's always motivating when you're watching these videos to see something and maybe you'll contribute to it or learn something from it otherwise. But anyways, let's get back to TCC here. So it's implementing basically the C programming language, almost, it looks like, to the C99 standard. So, probably things like C89, you declare all your variables at the top, and there's other sorts of restrictions. C99 is where you got a little bit more flexible. So anyways, it is one of the advantages of the C programming language being sort of this small, tiny programming language that you can, well, create compilers. I shouldn't say easily, but relatively easily to implement a subset of all the features. Now, C has a lot of different unofficial extensions that you'll find in GCC and so on. But anyways, C is a nice language in the sense that it is small, and as I tell folks, it lets you think about data and memory, which is ultimately what a computer is. Now, because it's small, it doesn't have all the bells and whistles sometimes of other programming languages, but some people like that. It keeps things simple, and you can just focus on the problem you're trying to solve. But anyways, with that said, Tiny C compiler is one of the relatively small compiler. Let's see, looks like it fits. It's about 100 kilobytes. So again, it fits easily on a floppy disk, and I think if you look through the Wikipedia, we won't read all of it. We don't need to read all of it. But basically, this is like a pilot that you could use like on an embedded system or bootstrapping a kernel or something to compile some C code. So it's really cool, and it is an advantage to have a small sort of code base to compile C code, which much of the embedded world still uses. It's kind of cool to see that there's 3 targets here. You have your 32-bit x86 machines, 64 ones, and then the ARM machines as well. So that's pretty impressive that works here. And there are some optimizations, I believe, as well. And the Tiny C compiler itself has its own linker, assembler, all these different things here. It is its own full, complete tool chain, which is pretty cool. Okay, so let's see what the compiler program performance is about here, because again, if it's 9 times faster than GCC, that's pretty cool. But again, it's on an emphasis basically of, well, let's see, smallness instead of optimally performing results. So again, we're getting that speed of compiling our program really fast because we're not trying to apply every single optimization, or I should say that's the goal of this project rather, versus a compiler like GCC or Clang, which is LLVM based, right? Those are applying lots of optimizations, doing lots of intermediate code generation things, being able to target lots and lots of different and targets or machine code that they can generate and so on. So again, different goals, but it is very advantageous to be able to, as a developer, just compile your code fast and get an iteration of, did this fix the bug I was working on? And then for your release version for your consumers, then you can compile the, optimized version and of course test that to make sure it's equivalent. But that's the sort of principle here. So again, there is a place in the world certainly for fast C compilers, fast C++ compilers, fast etc. I learned this from D because the D compilers, if you go to the downloads, right, there's three. There's DMD, that's the reference compiler, very, very fast compilation. But then you have the GCC and LDC compilers, which have the LLVM and GCC backend for, when you're releasing to your consumers and want to take advantage of the decades of optimizations and compiler research that have been put into these things. So again, I learned that from D, and it was cool to see D linked here. I'm not sure exactly the context here, but we'll see some similar ideas with TCC. So anyways, all right, so let's see. How do we get the performance here? I mean, let's see. So we optimize the smallness to get the performance here. TCC generates code in a single pass. So again, that's going to be I think one of the big performance things, right? As soon as it's parsing your code, it's also generating the code, right? There's no, maybe there is some intermediate form being generated in this single one time through, but it's basically saying, here's the line, okay, here's the assembly effectively. And that's how you can get your code generation much, much faster. But, that's at the cost of maybe not performing all the optimizations. It is still performing some, which is cool. Which I saw down here, but anyways, that's the idea. So TCC compiles every statement on its own, and at the end of each statement, register values are written back to the stack, must be reread even if the next line uses the value in the registers. Okay, so that creates extraneous save load pairs between statements. I'll have to think a little bit about why they're mentioning that here. TCC uses only some of the available registers on x86 and never uses some of the reserved registers. Okay, so it makes sense. And it performs a few optimizations as mentioned. Constant propagation for all operators, multiplication and divisions are optimized to shifts when appropriate, which is great. Shifts tend to use fewer cycles. Comparison operators are specifically optimized by maintaining a special cache for the processor flags. It does the same it does some simple register allocation, which prevents many extraneous save load pairs inside a single statement. Okay, so anyways, again, we're trading off speed of compilation for total optimization here. Okay, so I think that gives us a gist of what's going on here. It's being used here. This is kind of impressive. I guess there was a patch version, but TCC could actually compile GCC. So I wonder what version that was when that was added here. So anyways, and a little bit about the history here. Its origins in the obfuscated Tiny C compiler. So there's this obfuscated code competitions. Here it is. Yeah, International Obfuscated C Code Contest. Folks should take a look at that. Some of the examples are quite impressive, what folks can come up with there. In fact, if we just kind of take a peek at the wiki here, I wonder if it'll have any samples. You can see all sorts of weird stuff. Yeah, I mean, this is what the code kind of looks like. But, it's all just data to the computer. They don't care if it looks pretty, our computers. So anyways, that's the idea here. So anyways, here's a status of the project according to the wiki, but the mailing list is still active when I browsed around there. So anyways, let's try to actually compile this. I think a good benchmark would be for us to just see with, I've got GCC 14, so if I compile this code to see how long it takes, and then we'll just use the compiler to see if it can compile itself in some amount of time here, because there's about 76,000 lines of code, including the headers. Let's see here. And then because of the headers here, that's, let's see, almost 2 million lines of code by the time stuff gets like processed and included and so on. So that's a pretty good benchmark here. Let's see if we can just download it here. Let's find the Linux version here. Let's see, I've got a tar here. Let's see if we can get like the latest release here. Probably, let's try this one here. And what's this? BusyBox. Okay, then we got Windows versions. Okay, this will do fine though. So let me just bring that in here. Here it is, TCC. Okay, seems reasonable enough here. Let's figure out, do we have a make file? Okay, we've got configure. So I'm assuming I should run configure and then make here. Here's our make file. Let's see on our readme here. Let's open this up here. Let's just open up this folder here. Okay, open in terminal. Okay, let's see what we got here. Let's open up the readme. Features. Okay, we know all about the features here. Okay, to install, we'll run configure. So it figures out that I have a x86 machine here. Make test, make install. Okay. And I guess we will just have to see if I can finagle after I do this build here, if I can change the compiler in the make script or something to just like rebuild it somewhere. So anyways, we'll figure that out here. Let's just kind of poke around here. Let's see what's going on in the, what is it, the configure script here. Let's see here what we got here. Okay, there's our compiler GCC, so maybe I'll change that around later. But let's see here. I should be able to just time this with make, and that should be okay once we get our build. Otherwise, we'll have to find some other code or something to benchmark against here. Okay, so let's see. Let's run configure. Okay, that was easy enough here. Let's time our make here. And let's see here, which I guess I can look here. I mean, this won't be a perfect test here. Okay, made in 5 seconds here. Now it looks like there might have been a bug. Malloc hook undeclared here. Okay, so we'll have to see if that caused some problems. Make. Entering directory, download, lib, etc., etc. Malloc hook undeclared. Now, doing a little bit of research here. As I pause the screen here, it looks like some folks are saying I'm working on a very old version and we should try the mob version from GitHub, okay, that we saw earlier. So let's go ahead and let's try that here. That seems more reasonable to me. Let's see. Unofficial mob development branch here. Okay. This looks pretty official to me. TCC. Okay. Let's clone the repository. I like to do that. And I'm assuming this one's going to get tested more often, and it looks like we have the same instructions here. Okay. So we'll do a little restart here. And that's just a good notice for folks here. Let's go to our home here. Let's get clone. Let's do this in... Well, it's going to put it in TCC experiment here. Let's go ahead and clone there. Because I'm going to want to do a couple builds here just to see if I can get things up and running. Okay, so let's see here. So we're going to run configure. Hopefully it'll work here. Let's run make. Let's time it here. And our version, I guess it's defaulting to 13 here. And it looks like it built here. That's good news here. Make test. Okay, so it's doing some testing using TCC. That's good news. And we'll do a make install here as well. That's always good. Now, something interesting I was thinking about here, perhaps another use case for this, or these types of compilers here. Let's see, permission denied here. Type in my super secret password. There we go. And now I should have TCC available. Let's see if it has like version or something. There we go. So there's a version here. I guess it's bumped up to 0.9.28 release candidate. So again, getting really close to that 1.0 release here, which is neat for, you know, whatever folks are, whoever is still contributing to the project. Anyways, the thought is with, you know, let's say we have GCC, which we're normally using, or G++, or one of these faster compilers, really for that matter for any programming language. But what if I wanted to build my shared libraries and like hot reload them in my code and just use something like TCC to do that? That could be a potential use case, at least for the development experience. That might have value, right? So you can compile code really quickly, load it into your program that's running. So again, there's a lot of different use cases for this. Again, coming from the D world, right, we have this RDMD tool or DMD run that we can use to just basically execute code as a script. You can do that with TCC, which I saw on the homepage as I was investigating this. So if I go back here, and I think on the online documentation, let's go to the introduction here. Let me show you some of the cool things here, right? Where you can just basically do tcc run here. So we should try this with like a little hello world program here. Let's just go ahead and make a directory called programs. And let's just pop into there. Hello C. So let's see if we could just use the standard C headers and these types of things here. Let's return 0, printf hello from TCC. Put a little end line there. Okay, so let's just do TCC hello and run here. I'm not even going to bother with all the executables and stuff. And there you go. No compile, no link step. It's just, it is what it is here. And I'm assuming the build or something, maybe the build gets cached, maybe it just gets thrown away in a temporary directory, but it builds it and runs it, and that's kind of nice here. So again, that's something that I really like. Now let's see if I just do this, what the result is. Okay, I get my a.out file, and there it is. Okay, so that's really cool that works here. Now, for our experiments here, we want to see if TCC can build itself here or compile itself, I suppose here. I mean, we did a little experiment with make, I suppose, to see how the build process is. So let's kind of do this again here. Let's do a git clone here. Let's just do it in, let's just call this TCC build. Let's go into the TCC build. Let's get clone into here. So I've already got the compiler built, but I'm just going to change it to see if it'll build itself here. So tiny TCC, because again, what was our experimental result previously? 6 seconds, something like that. Scrolling up a little bit. I ran the tests. Sorry about that. Maybe I shouldn't have done that, but hey, I got a nice little test suite there. That's nice. Might just have to rebuild it again, but I'm pretty sure it was 6 seconds, something like that. There it is. Yeah, 6 seconds. Okay, so we're going to see if we can go faster than that here. Okay. Let's see here. And really we care about the user time here, so I should accurately do that here. Okay, so this is in our build here. Now let's see here. I'm going to mess with the configure file to see if I change the compiler here to TCC, if it uses that here. Now, shouldn't need the linker here. Let's see here. How do I mean, is this going to be cheating here? Let's just see what happens here, if that's a good test here. Let's see. Configure is going to tell us if that works here. I think it worked. And I was going to run make again, and hopefully we see it start off with TCC here. Oops. I already screwed up my test because I didn't do a timer, but we do see TCC here. That's good news. Make time make. Okay, it ran like instantly because there's nothing to be done here. I've got to blow this away and restart. Okay, always be careful with your tests here. I could have done a make clean and all that kind of stuff, but anyways, let's restart our test. All right, let's get clone right here. And then we'll go back in the configure file. That's okay, it gets me to do this twice here. Configure, go down to line 30, replace with TCC here. That's all I did at line 30. And then we will time make. Oh, then we have a run configure, and then time make. Okay, and it ran really, really fast. Was that 9 times? Oh, that's like, well, let's see, 6.2 divided by 2, that's like 12 times faster. That's not too bad. Okay. Let's make sure if we do make test here, that should run all the tests here. Maybe the tests will run longer. We should test that as well here. I guess it just takes time, depends how long it takes time for them to build and so on. I think it passed all the tests here. So that's good news here. And we've got our other TCC here. Okay. TCC version. Yeah, pretty cool here. And again, this is in a different directory as the one that took 6 seconds to build here. Now, of course, the question is one of these builds faster than the other or whatever, or generating more optimal code. Well, maybe there were some optimizations applied on our TCC with compatible with GCC that this one didn't have. But ultimately, the algorithms that it's running are going to be the same, pretty consistent TCC. So you could do some more testing there. But I think it does hold up. I think it is, an order of magnitude, let's say around 10 times faster for generating the code here. All things being equal here, right? Just looking at the build. Let's scroll up here. Oh, we got to get past our tests again here. But right, here's where it did the main build here. Let's actually see how many lines of code is in like TCC, PP. I guess that's maybe the preprocessor, code generator, maybe debugger, doing something with elf symbols, the assembler, and then the run tool, which I briefly showed. Yeah, I mean, those are the main files here. Everything's in just this directory here. So if I run count line of code clock here, let's see here. I think I just run it on this directory. And it is telling us, let's see, how many lines of code do we have? 62,000 lines of C code, 39,000 of our header files. So yeah, not too bad there. And then there's a bunch of other stuff here, some shell scripts and assembly code and so on. So, let's call it in their range, almost 100,000 lines of C code, it's over that amount, I suppose. But the number cited from the website here, or where was it exactly? I forget, wherever. I think it was on the home page here. Yeah, here it is. Expanding out to, let's say, nearly 2 million lines of code, so 67 megabytes. That's pretty great. So yeah, we're doing 859,000 lines a second here. Okay, yeah, which would be about 29.6 megabytes. So pretty cool there. Pretty cool. Now I'm curious what this, what is this benchmark that they did here? Were they self-compiling itself? Because ours was much less than 2.27 seconds here. So anyways, just depends on the machine, I suppose. But let's look at some of the other features here before we wrap things up here on TCC. So again, we looked at this. I mean, this could be the main way to run our program. And this is a great way if you're just like showing off some examples, especially if they're larger, perhaps to just compile and run and execute them. Again, we have our arguments here. If we want to generate an actual executable, we can do that as well, which we demonstrated with our a.out. And we can link them and so on. So what else can we do here? Let's assemble but not preprocess. Let's see the assembly that's generated here in our Hello World program. So we got to go back into programs and let's just run TCC on hello C, and we should get our assembled. Let's see, that gives us our object file here. What do we want here? If I want an assembly file, can it just give me one here? Let's see, I can preprocess. Let's see here. It's usually -s here. Let's see if that works here. This is a single pass compiler. It may or may not give us that here. Let's see. Yeah, that's just garbage here. -s or dash. Let's see. ASM. Let's go ahead and see TCC help maybe, and let's see if there is assembly or assembler. I wonder if you can just get the assembler. It says it's got one out there. Let's see here. Compile only. It generates an object file. Output file name. Okay. Benchmark. Okay, so we got some compilation statistics. I wish more compilers had more stuff on this. D has F trace time. I'm sure GCC has some similar stuff, but always seeing the statistics is good. I'm not sure if I've seen that in as many of the different languages that I've looked at, but being able to see where you're spending your compilation time, like which function or which template or something is expanding is useful information, I think. to have. So anyways, let's just look through some of these. Oh yeah, these are all the linker options. Yeah, that's pretty cool, but I don't know if I'm finding the generate an assembly file here. Assembly, let's see here. Only supports, okay, most of the new ISO standard, many GNU extensions are supported. That's cool. Okay, we could do inline assembly, but do I have a dash output? Let's see here. Binary, some Windows stuff. Okay, not sure I know offhand if it does. I'm assuming it doesn't because of the speed. And actually, here I found some proof. This is from Brian Callahan, who does some awesome stuff on the FreeBSD side of the decompiler, actually. So here it is. Yeah, TCC does not output assembly. It directly outputs object files. Yeah, that's great in terms of speed, saving an entire step compared to, I guess, cproc, and GCC for that matter, is bound to result in faster compiles, all else being equal. Okay, so interesting, yeah. And we'll have to look at cproc perhaps later here. So anyways, this is from this article here. And Dr. Callahan does some really, really awesome work here, otherwise some engineering stuff and tutorials and so on. So anyways, just wanted to highlight that. Cool to see the answer from him. Okay, so that gives us our answer here, because it's going to say, I wonder if I could look at the actual assembly. I mean, we can. It gave us the object file, right? Just to tell you where we're at here. We can just output the object file, and then we could disassemble it using like obdump here, and then pass up the file here, and then we could try to look and see like how does this compare with something like Compiler Explorer. That was the example I was thinking about, but I mean this looks fine here for a little Hello World program, right? It's calling. You know, it's doing the minimum subset of things it looks like it needs to do for this program. But it'd be interesting to try it on a larger program just to see how much maybe we miss some of the optimizations in GCC. That being said, when you're just compiling regular old GCC, I wonder in the sort of like zero optimization mode, how many more optimizations you're getting. I'm assuming it's going to do kind of some of the similar stuff, maybe with dead code elimination and a few of those things. Maybe not a very aggressive dead code elimination, but maybe some of the things like the constant propagation and so on would be interesting. Another thing I didn't check with TCC, and let's go ahead and see here. We do have debugging information here. So that would also be important. TCC. Let's go ahead and run our Hello C program. Let's go ahead and build that. Let's output, I don't know, as prog here, and let's run it with GDB. I always like to do things in the text user interface here. So it does have the debug information, which is important. So that makes it a usable compiler in my book here. So that's a good thing here, right? We can start this. Run it, it'll print hello from TCC and so on. So that's good. That was the last little thing. You know, if you're going to build a compiler that's all usable, you probably need the debug information at the least here. If you know, you can get rid of a lot of the other bells and whistles, but at least for me, I would, you know, want that information. But you get the fast compiles, you can still debug it and step through it. You could build shared libraries with it, so you could hot reload it into a system that's always running. And that could be a great use case for something like TCC. And like we observed, you know, roughly 12, 13 times faster to compile itself, which is really, really cool to see here. So anyways, this has been on my list to do for a long time. I learned about TCC, again, from the some folks at the D conference a few years ago that mentioned it. You know, because I've been thinking a lot about fast compilation speed and these types of things here. So, and it's just maybe eye-opening for folks who, you know, in part this is, a lot of these videos are for folks just starting their engineering career to just know that there are other options out there, other compilers with different trade-offs, right? So that you can compile things 9 times faster, right? There are options that exist for that. So if you're just writing a tiny little C program and need to iterate a lot, consider adding this to your tool stack. And again, I think there's a lot of different variations of other C compilers. You could build your own C compiler. Again, as mentioned at the very start of this video, it's a small enough language that you can do these types of things. So anyways, with that in mind, we'll go ahead and start wrapping things up. Hopefully you had some fun here. There's some other cool features here, like there's a memory and bounds checker again, because when you're building your own compiler, you can do whatever you want here. So it looks like they incorporated some of these things. Of course, we have the sanitizers and so on in GCC and Clang and many other compilers, but this is kind of cool here that they have those features. So check out TCC. It looks like it's pretty well documented. There's 20 years or so of mailing list posts with probably tons and tons and tons of more stuff here. Some talks about the discussion here about the compiler. And of course, if you're building your own C compiler, there's a brief section here on the code generation, how that's done. So there are trade-offs that may or may not have been good ideas over the time, but for the sake of speed, they were made. So anyways, yeah, I think this is really nice kind of hidden project or something that at least you don't learn about right away as an engineer, that these types of things exist. You just default to whatever GCC or Clang install you got, and you think that's how it is. Or at least that's how I thought it was for a long time, until you see these other projects here. So anyways, hopefully that was insightful, hopefully just fun. Maybe I'll take a look at the project. And again, if you're building a programming language or a compiler or these types of things, hopefully it'll get you to think about trade-offs. So anyways, folks, let me know what you think about it in the comments below. Thank you as always for your time and attention. And let me know if you do compile some project with TCC, if you tried out, how much faster it was, to see if my little experiment was accurate at all. Of course, we can do a lot of different things with doing a real sort of performance experiment, but as a ballpark number, seeing that it is, yes, faster was a good sign. So let me know what you find. And anyways, I'll look forward to hearing from you, and I'll look forward to seeing you in the next video.